Today, we're going to be having some fun. We're going to go into our wardrobes and do some math. Now, in our wardrobe, we notice we have 3 shirts and 2 pairs of pants, and we want to determine the number of possible outfits that we can make. Outfits consist of 1 shirt and 1 pair of pants. So how many of those are possible? Now, if the answer isn't immediately obvious, we can work it out. So over here, we have our 3 shirts: black shirt, orange shirt, blue shirt. So let's start with the black shirt. Now, if you're like me, you're not very creative, and you think black goes with everything, so you wear a black shirt and black pants. Well, you and I think alike. It's not very creative, but it is the first outfit. So we could have black shirt, black pants. Now let's say you're a little more creative, and instead of black pants, you want red pants. So this could be the second outfit: black shirt, red pants. And it's the same thing for the orange shirt. Let's say you wanted the orange shirt, but you wanted black pants. That's the third outfit. Let's say you wanted orange shirt and red pants. That's the fourth outfit. Blue shirt and black pants is outfit number 5. And blue shirt and red pants is outfit number 6. And we see we've counted every possible combination. So when we count this out, we see that we have 1, 2, 3, 4, 5, 6 possible outfits. Now, some of you keen-eyed people might notice that 6, well, that's just 3 times 2, isn't it? That also gives 6. So we just took the 2 numbers that we were given in the problem and multiplied them together. So is this a coincidence? Well, when you really think about it, it isn't a coincidence at all. For each of our 3 shirts, we have 2 choices of pants, either the black pants or the red pants. So the black shirt has 2 pants, the orange shirt has 2 pants, and the blue shirt has 2 pants that it can go with. So the total would be 2 plus 2 plus 2. That is the same as 2 times 3, which gives 6. So we see that we can multiply these numbers together. Now, the reason we can multiply everything out is because in this problem, we have something called independent events. Big fancy name, I know. But don't stress too much about memorizing that term. It's not really important to memorize it, but it is important to understand what that enables us to do. Now, when we say independent events, we mean that the events in the problem do not depend on each other. So here, our 2 events were first selecting a shirt and then picking a pair of pants to go with it. And the pants that we choose don't exactly depend on the shirt that we chose. Completely ignoring fashion, I understand some people would never think to wear a black shirt and black pants, but in this problem, we're just going to completely ignore fashion. Our 2 events are independent, so we multiply them out. Now, independent events are not just restricted to 2 events. They can go beyond to 3 events, 5 events, even 10 events. And the more events there are, the less you'll probably be wanting to draw it all out. It was just nice to use a small example to understand why we can multiply everything out. But when we move on to more events, like 3 events, 5 events, we're not going to be drawing, we're just going to be multiplying. So now, let's get some practice with more events involved. Let's continue our discussion of independent events. Now tonight, you and me, we're going on a little date. We're going to be eating at a fancy, high-end, super expensive restaurant. And we both have so much money to spend that we've decided that we're each going to go for the 3-course meal. So we walk in, we sit down, we get our menus, and we notice we have a couple of options to choose from. We have 2 choices for appetizers, 2 choices for entrees, and 5 choices for desserts. Now you don't really care about anything but the food, so as soon as you sit down, you immediately start to think about what you're going to order. But me? I'm a little different. I don't think about what to order right away. Instead, I see a math problem. And I'm asking myself a little question. And that question is how many 3-course meals, consisting of 1 appetizer, 1 entree, and 1 dessert, how many of those can be ordered? Now, since you don't really care much about that question, it's up to me to answer my own question. So I notice we have 2 choices for appetizers. For each of these 2 choices, we have 2 choices for entrees. And for each of these entrees, we have 5 choices for desserts. So we see that there's a total of 2 times 2 times 5, which is just 20 different 3-course meals that can possibly be ordered. So I found my answer. I'm happy. That's great and all, but I think both of us can agree that there is one more important question that needs to be answered. And that is, who will be paying for these delicious meals tonight?